In the vast and dark ocean of the cosmos, there are worlds that fit perfectly within the rules science knows, and there are others that break them entirely. Today, we will travel to a planet that, according to our physical laws, simply should not exist. Most of the planets we find orbit stars similar to our Sun, or in some cases, cooler and longer-lived red dwarfs. We know that massive planets tend to form far from their star, while smaller ones can live closer in. This distribution is no accident. It follows planetary formation rules we have understood for decades, rules that this world seems to completely ignore. In 2019, the TESS Space Telescope detected strange signals from a star system about 284 light-years from Earth in the constellation Pictor. The star, known as HD 21749c, had been studied before, but this time something different appeared in the data. A transit that was too long, too deep for what anyone expected. When astronomers calculated the size and orbit, the surprise was immediate. A planet the size of Neptune, orbiting so close to its star that surface temperatures would exceed 800 degrees Celsius, and yet showing signs of a dense, stable atmosphere. According to classical planetary formation theory, a gas planet this large cannot form in such a tight orbit. The heat and intense radiation from the star should have stripped away its atmosphere over millions of years. And yet, there it was. Some researchers nicknamed it the Rebel Planet, though its official name became HD 21749c. But the story doesn't end there, because what came next would turn this case from strange to almost impossible. Could it be that the planet formed far away and later migrated to its current position? That's one possibility, but migration models suggest that in the process, it would have lost most of its atmosphere. Another more exotic theory suggested that the planet's core is extremely massive, with enough gravity to trap gases even in that heat. But if so, its composition would have to be unlike anything ever observed. When the Hubble Space Telescope turned its gaze to HD 21749c, it found something even more unsettling. The atmosphere contained traces of heavy molecules like water and methane, substances that, according to our simulations, should not survive so close to the star. This opened the door to a question no one dared to say out loud. What if we don't really understand how planets form? Or worse, what if this world did not form here at all? If HD 21749c truly formed far from its star, the migration must have been swift and violent, faster than any known example. That would mean the planet traveled through chaotic gravitational interactions, perhaps pulled inward by another, larger world. Yet, when astronomers searched for such a culprit, they found nothing massive enough nearby. It was as if HD 21749c had appeared in its current position out of nowhere. The planet's atmosphere presented an even bigger problem. Methane, water vapor, and heavier compounds can exist on distant gas giants where temperatures are low, but here they should be broken apart by stellar radiation in just a few thousand years, a blink in cosmic time. The mere fact that these molecules were still present suggested either some unknown mechanism was constantly replenishing them, or that the planet had arrived here far more recently than anyone thought possible. Then came the velocity data. Subtle variations in the planet's motion suggested a density far greater than Neptune's. That implied a rocky, metal-rich core unlike any other Neptune-sized world. Such a core could, in theory, trap gases under extreme heat, but this would require conditions we have never observed in nature. The more scientists studied it, the stranger the planet became. Theories began to fragment into speculation. Some proposed hidden moons, constantly venting gas into the atmosphere. Others whispered about tapture scenarios, where rogue planets wander between stars before being pulled into a new system. But there was one possibility so radical that most avoided it altogether: the idea that the planet's current state might be engineered. The engineered hypothesis began quietly, in the corners of research meetings, among scientists who knew how dangerous such ideas could be to their careers. The logic was unsettling. If the planet's orbit, mass, and atmospheric chemistry were all so improbable, perhaps they were not the product of random chance. One paper, never formally published, suggested that the planet's thick atmosphere could serve as an energy shield, absorbing stellar radiation and distributing heat evenly across its surface. This kind of climate stabilization, while impossible to achieve naturally in such proximity to a star, might be precisely what an advanced civilization would design for long-term habitability. Infrared scans from the Spitzer Space Telescope deepened the mystery. Certain temperature patterns in the planet's atmosphere did not match any known gas giant models. The readings hinted at unusual thermal hotspots, almost like localized regions of heat production. Natural explanations existed: volcanic activity, intense storms, but none fit perfectly. A handful of researchers began proposing missions, first with space telescopes and eventually with interstellar probes, to get a closer look. But before any plans could move forward, the James Webb Space Telescope provided an observation that changed everything. It detected faint, repeating fluctuations in the planet's light signature, as if something was periodically reflecting or emitting energy from within the atmosphere. The signal was too structured to dismiss as random noise, and yet no one could agree on what it was. The repeating fluctuations captured by Webb became the planet's most controversial feature. Every 11 hours, the signal would spike, precise, consistent, almost like a heartbeat. Astronomers initially blamed atmospheric storms rotating in and out of view, but storms are chaotic, not punctual to the minute. As data accumulated, the spikes revealed another pattern. They aligned with the planet's orbital position relative to its star, as though whatever was causing them was synchronized with the system's geometry. It was the kind of alignment you might expect of something on or near the planet was designed to interact with starlight in a predictable way. Officially, the explanation remained unknown atmospheric dynamics. Unofficially, it triggered a quiet race between research teams to figure out the cause before the news leaked into the public sphere. In an age of instant communication, secrecy in science is nearly impossible, and it didn't take long for amateur astronomers to detect the strange fluctuations themselves. Online forums began buzzing with theories: a megastructure, an alien relay station, even an abandoned colony. Most scientists rolled their eyes, but they could not ignore the fact that the signal's precision defied every natural model tested so far. If the structure hypothesis was correct, then HD 21749C's extreme location began to make more sense. A gas giant so close to its star would have immense solar energy available, a perfect power source. The dense atmosphere could protect whatever lay beneath it, acting as a planetary-scale radiation shield. And then there was the question of age. By analyzing the planet's orbital decay, its slow inward spiral toward the star, researchers estimated it had only been in its current orbit for a few 100,000 years. In cosmic terms, that's barely yesterday. If it truly migrated inward that recently, it might mean the process wasn't natural at all, something or someone could have placed it there deliberately. To test this, scientists modeled thousands of migration scenarios. None could reproduce the current conditions without invoking an external force. The math kept pointing toward the same improbable conclusion. This was not an accident. Still, extraordinary claims require extraordinary evidence. A coalition of astronomers proposed a deep atmospheric scan using Webb's high-resolution spectroscopy. They were hoping for isotopic ratios, chemical fingerprints, that might show if the atmosphere had been artificially altered. What they found instead was something far stranger. Mixed into the methane and water vapor were traces of compounds that, on Earth, are only produced industrially. Complex fluorocarbons, for example, stable in extreme conditions, resistant to ultraviolet breakdown, and highly effective at trapping heat. In our world, they are the byproducts of manufacturing and advanced chemistry. In nature, they are virtually non-existent. The official report carefully avoided the word artificial. Instead, it described the compounds as chemically anomalous and not consistent with abiotic synthesis under current models. But to anyone reading between the lines, the implication was obvious. Leaked fragments of the spectroscopy data began circulating online, and with them came a new wave of speculation. Could HD 21749c be a vast energy harvesting station cloaked in a gas giant's disguise? Or perhaps a terraforming project abandoned or still maintained by its creators? For the first time, serious voices in the field began to admit what had once been unthinkable. If this planet should not exist according to nature's rules, perhaps it doesn't. The debate over HD 21749c spilled out of academic journals and into mainstream media. Headlines ranged from "Scientists Discover Impossible Planet" to "Evidence of Alien Engineering?" Public fascination surged, and with it came pressure on space agencies to investigate further. Within months, an international mission concept was drafted: Vanguard, an unmanned probe designed to perform a high-speed flyby of the planet. The timeline was ambitious: launch within 20 years using next-generation propulsion, arrival a century later. Critics argued that by the time it reached the planet, the mysterious signals might have stopped, or the planet itself might be gone. Supporters countered that if there was even a chance of answering the question, it was worth the wait. But as preparations for Vanguard's preliminary studies began, the planet changed. The structured signal, so consistent for years, skipped a beat, then another. Soon, the 11-hour cycle began to drift, as if whatever was producing it was failing or adjusting. The change electrified the scientific community. If the signal was a natural phenomenon, the timing drift might simply be due to seasonal atmospheric changes. But if it wasn't, observations revealed another anomaly. The planet's thermal profile shifted. Those mysterious hotspots in the atmosphere began to multiply, forming a loose grid pattern across the equator. The geometry was striking: too ordered for weather, too stable for storms. Speculation reached a fever pitch. Were we watching the slow shutdown of a machine the size of a world? Or was this the prelude to something far more active? The data was inconclusive, but the timing could not have been worse. A solar storm temporarily blinded both Webb and other high-resolution instruments just as the changes became most pronounced. By the time the storm passed, the pattern had evolved again, now resembling a spiraling shape that wrapped halfway around the planet. The spiral was not static. Over the next months, it began emitting a faint but measurable beam of energy directed not toward the star, but outward, into interstellar space. The beam was tight, deliberate, and in a frequency band rarely seen in natural astrophysical processes. No one could agree on what it meant. Some claimed it was a distress signal, others an energy transmission, and a few believed it might be a form of propulsion, an attempt to alter the planet's orbit before it was swallowed by its star. Vanguard's mission concept was suddenly obsolete. A flyby in 100 years was useless if the planet was about to move or vanish within decades. A radical alternative emerged, a fast response probe using experimental solar sail technology, capable of reaching the system in just 20 years. Still far too slow for immediate answers, but fast enough that the same generation might see results. As the world argued over the feasibility, HD 21749c made its most dramatic move yet. The spiral beam abruptly shifted and pointed directly at Earth. For 72 minutes, the beam remained fixed on our planet. It was too faint to be visible with the naked eye, but instruments picked it up instantly. Inside its narrow bandwidth, the signal was structured, compressed bursts of data in repeating sequences. It was not random. Decryption proved impossible at first, but what unnerved researchers was the pacing. The signal repeated exactly 3 times, then stopped. The planet's strange atmospheric patterns dissolved within weeks, the regular pulses vanished, and the world returned to its impossible but dormant state. To this day, no one knows what the message contained, or even if it was meant for us. Some believe it was a warning, others an invitation. A small but vocal minority insists it was simply a test to see if we were listening. HD 21749c still orbits its star, silent and steady, defying the laws of planetary science. And every so often when astronomers aim their instruments at it, they can't help but wonder, did we just witness the last breath of a dying machine, or the first sign that we are not alone?
If this story made you question what's really out there, imagine what else we haven't found yet. Hit subscribe so you don't miss the next deep dive into the mysteries of our universe. Share this video with someone who loves space as much as you do, and let's see how far we can spread the question, what else is hiding in the dark?